Hey, what's up guys? This video is for section 10.5, which is the Pythagorean Theorem. Now, this theorem is used when we have a right triangle. So first, let's look at what is a right triangle. A right triangle is a triangle with one 90-degree angle, aka right angle, two legs, and a hypotenuse. Now, you can see the picture of a triangle on this side of the screen, and we do have two legs with the third side of the triangle called hypotenuse. The hypotenuse is the longest side of a right triangle. That side is always across from the 90-degree angle or the right angle. In geometry, we have a symbol or a box to state that an angle is 90-degree angle. This box that you see here in the corner of the triangle, which is a square, it's telling you that it is a 90-degree angle. So the 90-degree angle and the hypotenuse, they're across from each other. So every time you are looking for the hypotenuse, look for the 90-degree angle and the side across from it or on the opposite side. That would be your hypotenuse. It's also the greatest side of the triangle and is away from the 90-degree angle. The other two legs, this leg and the other leg, they are going to be different lengths, and we do have a theorem to find those lengths or measurements of the three sides of a right triangle, which is called the Pythagorean Theorem. This theorem helps us find either the hypotenuse, either one of the legs, but we need to use the theorem, substitute numbers, and simplify, solve for the variable or the side that we are looking for. So let me explain what the Pythagorean theorem says. In symbols, the Pythagorean theorem says c squared equals a squared plus b squared. So let's go ahead and go back to this picture over here because I have those labeled for you so you can see how to use the Pythagorean theorem. C squared is going to be your hypotenuse. That's going to be your longest side. Equals a squared is going to be one side of the triangle plus b squared is going to be the other side of the triangle. What does it mean? It means that if you take the length of A, side A, you square it, and you add the length of side B and you square that side, and you find the sum of the squares of A and B, that's going to be the same measurement as the hypotenuse squared. If we know that theorem, if we know that's true, then we can find any missing side of the right triangle. You can see another triangle on this side here. Notice that A, if you pay attention a little bit closer, A is shorter than B, C is longer than A and B, and here's the 90-degree angle. So remember that the side on the other side, the opposite side, or away from the 90-degree angle is your hypotenuse. So when you're looking for C, the side away from the 90-degree angle, that is your hypotenuse, and the other two sides are going to be your a squared plus b squared. So let's try an example and find a missing length from that triangle. Now, it says here that we can round to the nearest hundreds if it's necessary. If we get an irrational number or if we get a decimal, we can round to the nearest hundredth place, which is two decimal places in that decimal. Now, let's look at the triangle on the left side. First, let's understand the problem. We do have a triangle. We have a right angle, that is your 90-degree angle. And we have two sides, 10, 24, but we are missing the third side, that is your variable c. Since this side is the one away from the 90-degree angle, or you can say on the other side of the 90-degree angle, that is your hypotenuse. That is going to be your actual longest side of the triangle. So since it is a right triangle, we can use the Pythagorean theorem. I'm going to write that down. C squared equals a squared plus b squared. And you have to pay attention to the variables that you guys are going to substitute. First of all, your longest side, the side away from the 90-degree angle, is your hypotenuse. This length C, we do not have the measurement. So that's going to stay as a variable because that's what we are going to look for. A usually is the shorter side of the triangle and B is longer than A. So when I look at the other two sides of the triangle, A is going to be the smallest side and B is going to be bigger than A, which is the other side or the second side of the triangle. I'm going to substitute those values into the formula, and when I do, I have to be careful where I substitute because I'm not going to substitute anything to the C because that's going to be my hypotenuse. That's what I'm looking for. I do have A, which is 10 squared, and I do have B, which is 24 squared. Now you guys need to simplify, and then we need to get C by itself. So I'm going to use my calculator. I'm going to put C squared equals, and I got decimals already on the screen. So up here where you see the expression, I put parentheses 10 squared plus 24 squared, and we got 676. So I'm going to write that down in after the equal sign. C squared equals 676. Now remember that we need to get C by itself, so we need to cancel the squared. The opposite of a squared is the square root. So I am going to use the square root on this side to cancel the squared, and whatever you do to one side, you're going to do it to the other side. So you cancel the squared and the square root. So we're going to have C equals, and let's go ahead and use decimals. And using decimals again, I have the square root of 676 is going to be 26. Now, if you go back to quadratic equations and using the square root property, remember that when we solve using square roots, we need a plus and a minus. Mathematically, this equals C equals plus or minus 26. But since we are looking for the measurement of a length of a triangle, well, the length of a triangle, it will never be negative. So in this case, since we are looking for that length, we are going to say that C is going to be the positive answer, which is positive 26. So you don't have to worry about the negative because for measurements, we're not going to use negative length or negative measurements. So the value of C equals 26. Let's try the triangle on the right side. First of all, let's understand what we have in the triangle. So this triangle is flipped. The orientation of the triangle doesn't matter as long as you pay attention and understand the problem or the triangle, how it is set up. So looking at the triangle, I notice I have my 90-degree angle here. So my opposite side or the side away from it is the hypotenuse. That's going to be your C. And I'm going to label that so you guys know this is C. We have the measurement of C. C equals 15. The one on the bottom of the triangle is B, and that's what we do not have. So we are looking for that length, measurement of length B. And we do have the side on the right side, which is the shorter side, which is A. So 7 is going to be A. Let me just put an A on the top. So when we use the Pythagorean Theorem, that's going to be C squared equals A squared plus B squared. So I'm going to substitute the values that I know. I know C and I know A. So I'm going to substitute 15 into the C, and I'm going to use the squared. I'm going to substitute the 7 into the A, which is A with the squared, plus, so this is the Pythagorean Theorem, B squared. So let me go back and let me repeat this again. We have the C squared, 15 squared, equals your A squared plus the B. We don't have the measurement of B. That's what we need to find. Since we are looking for B, we need to get everything on one side and get B by itself. So using my calculators or my calculator, I'm going to square the 15 and I'm going to square the 7. So for 15 squared, we get 225. 7 squared is 49. And we have the plus b squared here. Let's go ahead and subtract the 49 to both sides. And when we subtract 49, subtract here and over here, we get 176 equals b squared. The next step is to get b by itself. So we need to cancel the square. So I'm going to take the square root of both sides, this side here and this side over here. Now remember, since we are using length measurements here, we're not going to use the negative measurement. We're just going to keep the positive. So using your calculator, you are going to find the square root of 176. The other side, we already know we're going to get b by itself because the squared and the square root will cancel. But let's go ahead and find the square root of 176. And we get 13.2664 equals b. And the decimal keeps going. But remember that the instruction says you can round to the nearest hundreds. Hundreds is the second number after the decimal. So here's the decimal. First number, second number. Since the number on the right side of the second number is more than 5, you can round up. So this one, 26, is going to become 27. So I'm going to have 13.27 equals b. So that is the measurement of side b. So let's try a couple more using the Pythagorean theorem. The triangle on the left side, it is a right triangle because it has a 90-degree angle. The side away from that angle is C, and notice we don't have a measurement, so that's your hypotenuse. So here we're looking for the hypotenuse of the right triangle, and we do have the two sides, A and B. So I'm going to write down the Pythagorean theorem. And remember, it is c squared equals a squared plus b squared. Since I don't have the value of c, this variable is going to stay the same. For a and b, I'm going to have to substitute the numbers into those variables. So remember that a is the shorter side, b is always bigger than a. So 6 is going to go into the a, 8 is going to go into the b. And I got those in the formula or the theorem, the Pythagorean theorem. Here's the a, 6 squared, plus here's the b, 8 squared. You can use your calculator to simplify this expression, but remember that you need to keep the c squared. So I'm going to break that down right now, and let me find out what is 6 squared plus 8 squared. And it is 100. Now to cancel the squared with the c has a squared, you are going to use the opposite of the squared, which is the square root. So you take the square root on this side, the square root on this side. You are going to cancel the squared and the square root. Remember that we don't need that negative measurement. So when you find the square root of 100, you just use the positive square root. And in this case is 10. So the measurement of c, which is the hypotenuse, equals 10. The triangle on the right side, well, it's also a right triangle. You guys have the 90-degree angle, which is the box or the squared in this corner. That means 90-degree angle. The one across from that angle is your hypotenuse. We do have it. It's 16. One of the sides is 12, but the third side is unknown. We don't know what it is. That's what we need to find, which is the value of 8. So when you write down your Pythagorean theorem, you are going to substitute the hypotenuse, which is c, into the theorem. So c squared, that's where 16 goes. A is going to stay the same, so you keep the a squared. B is going to be 12, so you substitute b into the theorem, and it's going to be squared. So when you substitute, it looks like this. You have the 16 squared equals a squared plus 12 squared. You need to square the 16 and the 12. And we get 256 equals a squared plus 144. We need to solve for a, so let's go ahead and subtract 144 from both sides. And when we subtract 256 minus 144, we get 112 equals a squared. And you guys can cancel the 144 on the right side of the equation. So now we need to cancel the square. To cancel the square that has the a has a square, you are going to take the square roots of both sides right here. So you are going to cancel the square and the square root, and you bring down the equals. Here's the a, and the square root of 112 is 10.5830. But let's go ahead and round to the hundredths, which is 2 decimals, or 2 numbers after the decimal. So I'm looking at the 8 here, and the number on the right side of the 8 is not 5 or higher. So it's lower than 5. So that means that this 8 stays the same. You're not going to round up. So it's going to be 10.58 equals a for that length. Remember that we don't use negatives for measurements for length. So we're just going to keep the positive 10.58. Now we're going to talk about the converse of the Pythagorean theorem. This is used when you want to check if a triangle is a right triangle when you're not sure if it is. We know that a right triangle is when you have a 90-degree angle, but sometimes we're not sure, we don't know if it is a 90-degree angle. I know that this picture or diagram here, it has a square, so that is telling us that it is a 90-degree angle. But let's imagine that you don't know it is a 90-degree angle, and we don't know if the triangle is a right triangle. So using the Pythagorean theorem, I have c squared equals a squared plus b squared. I can substitute the given length of the triangle, the 3 sides, and I need to make sure that the Pythagorean theorem is a true statement when I simplify using those measurements of the triangle. Notice that one side of the triangle is longer than the other 2 sides of that triangle. So the longest side is the hypotenuse, the one away from the 90-degree angle. So that's going to go into your c variable. C is your hypotenuse, and the other 2 measurements are going to go into the a and the b. A is the smallest side of the triangle. B is always bigger than a. So when I substitute, I get the 5, which is the hypotenuse, squared, equals the 3 squared plus the 4 squared. When I substitute both sides, notice 5 squared equals 25. The other side, 3 squared is 9, 4 squared is 16. And when I simplify, 25 on the left side, and 9 plus 16 is 25 on the right side. This statement is true. So when that statement is true, that means that the triangle is a right triangle. Using those measurements, we can make a right triangle. Now, those special numbers that actually make a right triangle are called Pythagorean triples. Triples because they're 3 numbers. Any 3 numbers or triple numbers that works with the Pythagorean theorem are called the Pythagorean triples, which means that if you use those measurements, you can make a right triangle. Some examples are the ones that we use right now, the 3, the 4, and the 5. Another set of triples are 5, the 12, and the 13. Now also, multiples of the Pythagorean triples make a right triangle. Multiples are the numbers that you are counting by using those triples. So notice here I have a 6, 8, and 10. Those are multiples of 3, 4, and 5. 3 times 2 is 6, 4 times 2 is 8, 5 times 2 is 10. So those are multiples of those triples. So they're also going to make a right triangle. So let's use the converse of the Pythagorean theorem to determine whether each set of measurements can be length of the sides of a right triangle. So I'm going to set up my Pythagorean theorem. C squared equals a squared plus b squared. Remember that the longest side of the triangle is your hypotenuse, which is c. So I'm looking at the measurements 9, 40, and 41. So 41 is going to be my c value. The shortest side is going to be my a, and the other one is going to be b. So I'm going to substitute into the theorem. And after I substitute the numbers into the theorem, the a, the b, and the c, I'm going to simplify both sides of the equation. Right now, I am not finished, but I just want to show you 41 squared is 1,681. 9 squared is 81, and 40 squared is 1,600. Now you guys are going to add the right side of the equation, and we get a true statement. These are equal. 1,681 equals 1,681. So do those measurements actually belong to a right triangle? Yes, they do. Let's look at the one on the right side, the three measurements, 17, 33, and 98. The longest side is going to be my hypotenuse, which is C. The shorter one is going to be A, and the third one is going to be B. I'm going to write down my formula, and I'm going to substitute, the Pythagorean Theorem, and I'm going to substitute into the theorem. So you have to be careful where you substitute. Make sure you know which one is your hypotenuse, which is C, your C variable. So the longest one is going to go into C. We have the 98 squared equals A is the shorter one, 17 squared, and B is the other side, 33 squared. You're going to simplify both sides of the equation. So we get 98 squared equals 9,604. 17 squared is 289. 33 squared is 1,089. When you add the right side, we get 1,378. But the left side of the equation is 9,604. So this is not equal. So this is false. That is going to be a false statement. They're not equal. So are those three measurements from a right triangle? We say no, they're not. So I'm going to put a no here. So you guys learned about the Pythagorean Theorem. You guys now can identify if the measurements of a triangle will make a right triangle, and you can also find the missing length in a right triangle using the Pythagorean Theorem. This is the end of my video. I want you guys to practice. Remember that more practice you have in math, the better you guys will become at math. So make sure you guys practice. If you guys like my videos, click that like button. You can subscribe to my channel. I'll see you guys later.